Hello and welcome to the first Star Sailor podcast with Peter Clark and Hannah Hutchins. Today we're discussing the latest reincarnation of Galaxy Zoo, Hubble Zoo.
So Hubble Zoo is a citizen science project that uses the general public to classify a whole host of Hubble galaxies, focusing on their morphology.
For those of you who aren't well versed in astronomical terms, morphology literally means the shape of a galaxy. The previous Galaxy Zoos discovered some very interesting trends between the morphology of any particular galaxy and its location and its distance from the Earth, also known as its redshift. Hubble Zoo is designed to take this analysis to the next level and provide an even more detailed analysis of lots of galaxies so that conclusions can be drawn over a wide dataset.
So the previous Galaxy Zoo projects 1 and 2 used data from the Sloan Dual Sky Survey database.
Thankfully we can shorten this to SDSS, which makes it much easier on us for the podcast.
So the SDSS database mostly has galaxies of relatively low redshifts, so the galaxies are lurking mainly millions of light years away.
We should add now that redshift isn't a direct measure of distance. It's actually a measure of how the light from a particular galaxy has shifted to one end of the spectrum. This can be either blue or red. As most galaxies are moving away from us, the light is stretched into longer wavelengths, meaning they are redshifted. The more the light has been redshifted, the further away the galaxy is, so it allows you to calculate a rough estimate of distance.
The opposite of redshift is blue shift, which means that the light of the galaxy will be shifted to the bluer end of the spectrum as it's moving towards us.
This happens because the light is essentially compressed into shorter wavelengths, so it appears bluer. The most famous example of a blue shifting galaxy is the nearest large galaxy to the Milky Way, the Andromeda, or M31. It is in fact on a projected collision course for the Milky Way and should collide with us within the next few billion years. Don't worry, it's not something you should be worried about.
The Sloan telescope's aperture,
which is a very fancy word for mirror,
is 2.5 meters, whereas the Hubble telescope's aperture is 2.4.
Generally speaking, the larger the mirror you have on a telescope, the better images it can produce. Despite this, Hubble sits above the Earth's atmosphere, and so despite it having a smaller aperture, it can take much better photos, as I'm sure you've all seen from the Hubble press releases.
So because the Hubble telescope is outside of the Earth's atmosphere, it can see further back in the universe's history as much as billions of years.
This means that Galaxy Zoo is now able to study galaxies as they were forming, rather than long after the formation process was complete. This is allowing Galaxy Zoo to put together an idea of how galaxies in general form and how the formation process between, say, an elliptical and a spiral differ. Galaxy Zoo has already discovered many interesting objects, as well as a completely new type of galaxy known as the Ps.
The Ps are highly compact galaxies which are star-forming at incredible rates.
This rate is many times that what is currently occurring in the Milky Way.
The Milky Way churns out 1 to 4 stars a year, whereas the Ps can churn out up to 40 Sun-like stars a year.
As you may have guessed from their name, the Ps on the SDSS appear green, small and round and, well, pea-like, hence their name. They were first identified as a bit of a joke on the forum, but what turned out from 1 or 2 turned into an entire collection that became impossible for professional astronomers to ignore.
Followed inevitably by loads of puns about garden peas.
And, well, give peas a chance.
Yes.
Which you can still find in the forum. Whilst the Ps are incredibly interesting objects, they are by no means the only objects discovered by Galaxy Zoo that are completely out of the ordinary. One of the most famous is of course Hani's VooWarp. The VooWarp lies just outside the spiral galaxy IC 2497. Yes, astronomers are really inventive at naming things. The VooWarp is believed to be a free-floating cloud of ionized oxygen without any sign of star formation at all. Currently, the most popular theory for what caused the ionization of the gas in the first place is a residual light echo from IC 2497's once active nucleus, which has since become inactive, and so we are seeing the residual trace in the gas of the VooWarp. It is also believed that eventually the VooWarp will fade from view as it loses the rest of its energy, and just become one other boring cloud of hydrogen gas sitting in space. The discovery of the VooWarp sparked a hunt within the zoo for any other ionized gas clouds found within the SDSS database. No other VooWarps were discovered, however an interesting class of galaxies were discovered in the process.
The Fulverpes, though we're not actually quite sure how you pronounce that, so we just call them floor pies.
It is Dutch for small object, in case you're interested.
These galaxies have massive clouds of ionized oxygen, hydrogen, thousands upon thousands of light years wide. These clouds of ionized gas are ionized by the supermassive black hole at the center of these galaxies. Material is falling into the black hole in a donut-shaped accretion disk. And as the material speeds up around the black hole, like water going down a plug hole, it releases a heck of a lot of energy, such as ultraviolet and X-rays. So as the radiation is emitted by the center of the galaxy, the radiation then strips the hydrogen or oxygen clouds of their electrons, therefore ionizing the gas and lighting it up. So as you look at the SDSS images, you can see massive pink or blue clouds stretching across the galaxies for up to 90,000 light years.
They really are very interesting objects to look at. See if you haven't hooked through the Sloan database. We've picked out some of our favourite Volverbies and put them in the slideshow. To finish up with, we would like to invite you all to come and join us at Galaxy Zoo. You can help contribute to citizen science and make a real impact on astronomy as a whole. The website is completely free to sign up for, and it's incredibly fun. If you'd like to join us, it's at www.galaxyzoo.org. If you need a link direct to the site, you can find it in the description if you're listening to this off YouTube, or in the post below if you're reading this off the Witty Astronomer's blog. Galaxy Zoo is also famed for its forum, with an incredibly friendly place where like-minded people can talk about everything from the galaxies they're classifying, their favourite taste in music, coffee, socks, chocolate,
elephants,
gardens, you never know.
Marshmallows.
It's a rather diverse place, so if you want to come and join us, we'd be delighted to have you at www.galaxyzooforum.org. Again, that's in the description or in the post below. We hope you've enjoyed listening to the first Starsailor podcast, and we hope to do this reasonably regularly. Again, we hope we haven't been too boring for you, but thank you for listening.